Okay, guys, this is Abi, the tutoring. We are going to simplify the complex. In our previous lesson of Euclid in Geometry, part 1, we have concluded about the line from center perpendicular to the chord. Okay, so I'm talking about this reason here from the previous lesson from part 1. A quick recap. So we were talking about this. I hope you guys still remember that. And we said that our reason for this one, it is line from center. It is perpendicular to chord. Okay, so this was part 1. I hope you have learned a lot on our previous video. Okay, so today we are doing part 2 of Euclid in Geometry. Okay, part 2. This is part 2 of Euclid in Geometry. Okay, so what will be our reason today? So let me just give you the reason for whatever that we will be doing today. So whatever that we will be doing today, it will have a reason that angle at the center, it is equals to, okay, angle at the center, it is equals to 2 times angle at the circumference. At the okay, I'm not talking about circumcision. For circumference. Okay, guys. This will be our reason for everything that we will be doing today. Okay, so I just noticed that sometimes you might be confused that whether do you start with the one at the center or the one at the circumference. Okay, so it's always the center and the circumference. Okay, the one at the center, it is equals to 2 times angle at the circumference. Okay, even this one, just make sure that you don't miss this. Okay, so it is equals to 2 times angle. Then from there, which angle? At the circumference. Okay, so the one at the center, it is 2 times the angle at the circumference, like that. Okay, the angle at the center is equals to 2 times angle at the circumference. Okay, that's the reason enough. Okay, so this one, it has different dimension, guys, of which sometimes you might even think that things are not doable, only to find out that you don't understand this dimension. Okay, so I'm simply going to start with the first simple dimension. Let me do 3 dimension here, and then we will do other dimensions. Maybe we can do 2 down there. Okay, so now quickly, let's say that we have a center here, right? This is our center, and then we are having angle. Okay, let me do this. So here it is our angle that we are talking about. You see this angle? It is where? It is at the center. Okay, so now be careful. We have 2 angles on this one. Okay, we have this one, and then we also have another angle out there. Okay, but then we are not talking about that one. We are talking about the small one. So we are saying that this angle, we're saying that this angle, it is, oh, sorry about that. We're saying that that angle, oh Jesus, we are saying that angle, the one at the center, it is twice the one at the center. This one, it is twice the one at the circumference. So the one at the circumference, it is this one. Okay, so meaning that the angle at the center, it is twice the one at the circumference. Okay, meaning if here we have this angle being 90, that one at the circumference, it's going to be half of it. Okay, which is half of 90, which is 45. Okay, let's say that if we have this angle here at the center being 2x, that one at the circumference is going to be x. Okay, the angle at the center, it is 2 times bigger than the one at the circumference. Okay, the angle at the center, it is 2 times bigger than the one at the circumference. Okay, so now let's go for dimension 2. Okay, dimension 2, it might look a bit tricky, but then it's not really tricky. Okay, guys, so let's go for dimension 2. So this is dimension 1, okay, or version 1 of that. And then dimension 2, we are going to have something like this. Okay, and then that, right? And then we have that and that, and that, right? So if you can check, where is our angle at the center? Our angle at the center is here. You see, and then where is our angle at the circumference? It is there. Okay, so how do I know? Okay, I'll come back there. Let me just finish this. So it is the one at the center, it is twice. The one at the center, it is 2 times bigger than the one at the circumference. Okay, so if this angle here, it was 2y, the one there, this one is going to be y. Okay, so this is dimension 2. Let's go for another dimension which seems to be a bit different. Let's say that you have this. Okay, so where is our angle at the center? This is the one. It is twice the one at the circumference. So now let's go to the circumference. Okay, so it is twice the one at the circumference. Then now, where is the one at the circumference? Okay, now the one at the circumference is this one here, right? And then the one at the center, where is the one at the center? The one at the center is there. If this one is 2x, okay, let me use other variables. 2a, that one is just going to be a. Okay, so this angle here, if it's 2a, that one is going to be a. Okay, so now guys, there might be a bit of confusion on where do you put your angle. I just want to clear up that. I just want to clarify it quickly. Why didn't I put it here? Okay, and then why did I put that there? Okay, so now, and then why did I put this one there and that one there? Okay, so I would advise you that check now if your angle, you see we have this shape. Can you guys see the shape? This is the shape that we have on the first dimension. Okay, so and then the angle at the center, if you can check it now, it is outside our shape. Okay, then the one at the circumference should be inside. Okay, and then on dimension 3 or on the third version, now check the angle at the circumference, it is outside. Not to be confused with that one. No, the angle at the center, I'm really sorry guys, the angle at the center there, it is outside our shape. So the shape that we are having on third dimension is that one. And then the angle at the center, it is outside like that. And then of course the one which is at the circumference is to be inside like that. Okay, so inside, okay, outside, inside. Okay, outside, inside. Okay, so what can we conclude? So we can simply conclude that the angle at the center, you should check at your shape, especially for dimension 1 and dimension 2. Okay, so the angle at the center for dimension 1 and dimension 2, it has to be outside your shape. Okay, what do I mean by shapes? So remember, on the first dimension we have this shape. I'm sorry. So yes, we have this shape on dimension 1, and then now the angle at the center here, it has to be outside. So everything inside here, it is inside the shape, so I draw it there. It has to be outside, and then of course the one at the circumference inside, like that. Okay, and then now even on this one, our shape was like this. Can you see that? Now the angle at the center was here. It has to be outside the shape, so outside is that side, and then inside, the one at the circumference should be in the inside, is that one. Okay, I hope you get this. I hope I'm making sense, guys. Then cool. So these are the 3 versions or 3 dimensions. Angle at the center is 2 times bigger than the one at the circumference. Okay, so this is one of the most powerful theorems that you can remember. Okay, so let us try to get another 2 versions of these ones. Okay, so let us take this version and that version. Okay, so we are just going to get another 2 versions that you can come across. So here it is our center, okay, like that. Okay, and then from there we go to the circumference, like that. So this is another version. So if your angle here is angle P, 2P, let me say 2P, the angle there at the center, then that one there, it's going to be 1P, half of the one at the circumference. The angle at the center, central angle is twice bigger than the one at the circumference. Okay, so this is one of the versions, and then the last version that I want you to guys to know, it is this one that involves your diameter. Okay, so you have a diameter like that. Okay, and then you have that you have this. Okay, so here it's 90 degrees. Okay, so of course the one at the center, it has to be outside the shape. It's going to be this one. It's 180, right? It's a straight line, of course. It's 180. So if this one is 2x, that one, it will have to be half of 2x, which is x. Okay, so the angle at the center is twice the one at the circumference. Okay, so these are the 5 versions that you can think of. Okay, so I just want to make an emphasis, guys. Quickly allow me to make an emphasis with the different colors here. Okay, let me use red. Okay, cool. So what's happening here, guys? So the first angle, the one at the center, how does it get formed? So here is our center, guys. Can you see that? This is our center. And then from our center, there are 2 lines that moves to the circumference, both of them. They move simultaneously like that. The other one comes this side, the other one goes that side. Right? And then they form an angle there. This is the angle at the center. Okay? So they move from the center there, they go to the circumference. Right? And then when they arrive at the circumference, guys, notice that they are still going to form angles when they move from circumference to another circumference. Okay, so the angles that are being formed when they moving from the circumference to the other circumference, we do not consider them, but then we consider the angle that will be formed where they joined. Remember, these lines were from the same point here, and then they separated, went to the circumference, you see, at different places. But then when they separated, they formed an angle there. Okay? And then now, when they separated, they went to the different positions on your circumference. And now they are moving back to the circumference. And then they are joining again. So they go to a common point there on the circumference. This one moves from here and it goes there. And this one moves from here, it goes there. And then the angle that they form there, it is the one that we consider. And we call it the angle at the circumference. And then this one, it is the angle at the center. I hope you guys can see that. Same thing happens on the second dimension or second version. Okay, so we simply had a line here, right? I mean, we had the center here. And then we had two lines moving from the center, okay, going to different places at the circumference, which is this place and that place. So this one moved and went there, and this one moved and went there. And then they formed an angle, which is that one. Okay? And then now, they went to different places on the circumference. But then now they decide that, you know what, let's go and join back on the circumference. Okay, so firstly they move from center to different points on the circumference. And then now they are going to move from the circumference to circumference again, but then now they have a common point. Okay, so they're moving from here to there, which is a common point, and they form an angle there. So this is the angle that we are talking about when we say that the angle at the circumference. Okay, so the third dimension, let's check it quickly. The third dimension, so we had lines here. They are moving from the center to two different points on the circumference. They moved from here and came here, right? And then after they did that, they decided that, you know what, we are going back to join back together, but then on the circumference at the same point, but then on the circumference, not at the center. And they go like that, and they join there, and they form an angle there. I hope you guys get this. And again, the same thing happens here. They were moving from the center, right? This is our center. And then they go to different locations on our circumference. So this one went there, and then that one went there, right? And then they formed an angle there. And then now whenever they go back, they decide that we are going back, but then on the same point on the circumference. Okay, so this one moved here and went there, and that one moved from here and went there, like that, and they form an angle there. Okay, so I hope this is making sense. Okay, then the last one. These are the 2 points at the circumference, this point and that one. So these lines moved from the center. This one moved from here and it went there. And this one, it moved from the center and it went there. And after they have moved, they decided that, you know what, we are going back to join on the same point, but then on the circumference. The same point on the circumference. Then this one, they came to the same point like that, then they joined. Okay, so that's how you need to visualize them. Okay, so that you can understand whenever we're talking about the angle at the center and the angle at the circumference. Okay, why was I doing that? Because if we have another angles at the circumference, we have this angle here and we also have that angle there. But then these are not the angles that we are talking about. We are talking about the angles that they formed when they moved from circumference to join at the common point at the circumference. We are not talking about this angle and that angle. Okay, we are not talking about this angle and that angle. We are not talking about this angle here. Okay, even here we are not talking about this angle and that angle. We are not talking about this angle and that angle. We are not talking about this angle and that angle. Okay, I hope I'm making a lot of sense, guys. So these are the 5 dimensions that will help you to understand angle at the circumference, angle at the center. It is 2 times bigger than the angle at the circumference. Okay, so what else can I still share with you? So okay, let me just do some few examples on how do we answer that. Okay, quick example. Example 3. Okay, example 3. Okay, example 3. Now we have a question here. The question looks like this. Okay, we have a center O there, and we have this like that. Like that, and then we are told that this one here, it is 130 degrees, and there you have X. Okay, so this is a figure A, B, and C. Okay, so the question says that O is the center of each circle. Calculate X. So we want to know that X. Okay, so we know that that X, guys, it is half of 130. Okay, so X will be equals to half of 130 degrees. Okay, and then half of 130 degrees, it is 65 degrees. And then what is our reason, guys? Our reason is going to be angle at the center, right? I'm sorry, guys. Okay, what's happening about the angle at the center? It is okay, it is equals to 2. It is equals to 2 times bigger than the angle at the circum. Okay, so I emphasize again this part here. This part might make you to lose marks. So remember that it is equals to 2 times angle. It is equals to 2 times angle. Okay, angle at the circumference. And then now if they were to mark this for you, they were going to give you 1 mark for that and 1 mark for your reason. Okay, so reasons are very important, guys, are very crucial. Then let's take another one quickly. Okay, so we have okay, let me use a blue pen. Okay, cool. We have a circle like that, and we have O there, and then we have 2 lines moving from O like that. Okay, so and then they formed an angle here, and we are told that angle is 50 degrees, right? And then they go on your circumference at a common point, and then they form another angle there, and they decide to call it Y. So they want us to tell them what is that angle Y. After what we have learned, we will know that the angle at the center, it is equals to 2 times the angle at the circumference. Okay, so what do we mean by that? Now our angle at the center, it is 50. So meaning that the one at the circumference, it is half of 50 degrees, and then half of 50 degrees, it is 25 degrees. And then now what is our reason? Our reason is going to be angle at the center is equal to 2 times angle 2 times is equals to 2 times angle at the circum. Okay, then you have a mark for this one and you have another mark for that one. Okay, another one, let's say that you had this one, looks like this. There is your center, and then now you have this line emanating from the center going to your circumference, 2 of them, and then from the circumference they move from the circumference, they go to a common point on your circumference. Okay, so they form angle there, and then they also formed another angle there. Remember, Salata side, got this one. The angle with this shape, the angle at the center there, you can see that it's outside. Okay, so and we are told that this angle here is 270 degrees, like that. Okay, so if this angle is 270, then what about the one at the circumference? Pre-metric length, that's easy. The one at the circumference is going to be half of 270 degrees. It is going to be equal to that angle at the circumference. They just called it Z. But then now, what is it, half of 270? Is it 135? Yes, it is 135 degrees. It's equals to that angle. And then what will be your reason? Angle at the center is equal to 2 times angle at the circum. Okay, so that's it, guys. This should be very, very, very easy and interesting. Isn't it interesting, guys? It's so interesting and easy. Okay, we still have 3 minutes. I think I can still take chances and do another example. Okay, so quickly let us take example 4. Example 4. Okay, so we have another circle there, and here is our center O, and then we have 2 lines that emanate from the center going to the circumference, like that, and then they form angle X there, and then from there they move from our circumference to circumference, but then now they go for a common point, and then we are given that there it's 62 degrees. Okay, and then we are asked to calculate X there. What is X? It's simple, guys. We know that the angle at the center is 2 times bigger than the one at the circumference. Okay, so now since the one at the circumference it's 62, so now X is going to be 2 times 62 degrees, and our X is going to be 124 degrees. And your reason is going to be what? Your reason is going to be angle at the center is equal to 2 times angle at the circum, like that. And then you just get your marks, 1 there, 1 there. Okay, then you go to metric, you pass with distinctions, and you go to tertiary, and you become whatever that you would like to be in future. Okay, so cool. Another problem here. This is our circle, and then we have there our center, and we have 2 lines going there, and we have Y, and those lines are moving from there, the circumference, and then they are going to join on a common point on the circumference, and you have 23 there. So this is simple as well. We know that the angle at the center is twice the one at the circumference. So y is equals to 2 times 23 degrees, right? And y is going to be 46 degrees. Okay, then what's your reason? You're simply going to say that angle at the center, angle at the center is equals to 2 times angle at the circum. Then you simply get your mark there and your mark for your reason. Okay, last one. Here is your work, guys. You need to complete this work, but then let me just do the last one quickly. There we have our circle. Okay, then our center there. Then we have lines from the center to different points on the circumference, and they form angle there. And then from there, they move from the center, they go to they move from the circumference, different point, they go to a common point on the circumference. And we are told that the angle there is 126. Remember, this kind of a shape, the angle is outside there. So they want us to find the angle Z for them. Okay, that angle there. So we know that the angle at the center, it is twice the one at the circumference. Okay, so we are simply going to say that 2 times 126, it is equals to Z, right? And then 2 times 126, it's 252, right? 252 degrees. Don't forget degrees, guys. Okay, and then what is your reason? Your reason is just going to be that the angle at the center is equals to 2 times angle at the circum. And thank you, guys. Keep well. I love you so much, and I hope you enjoyed this lesson, which was part 2 of our Euclidean geometry. Okay, so quickly screenshot these exercises. So this is exercise 1. This is A, screenshot it. Then this is your B, screenshot it. This is your C, screenshot. Let me try to shrink it a bit so that it can be. Okay, so this is C. I hope you can screenshot it. Then let's continue. This is D. Can you screenshot it? And then this is your E, screenshot. And this is your F, screenshot it. And for exercise 2, this is A. Take the screenshot of this. This is A. You can take the screenshot. This is A. Screenshot it. I hope you are done. Let's go. This is B. Take a screenshot. And this is C. Take a screenshot. Okay. This is D. Screenshot. Right? And then this is these are repeating. This is E. Take the screenshot of that. Take the screenshot of E, followed by F. Take the screenshot. G, screenshot. And H, screenshot. I love this one. And I take the screenshot of that. This is very nice. And after I, this is your J, take the screenshot as well. And yeah, then we are done. Okay, so guys, you are just going to do that homework and submit it. The reason why it's long is because on part 1 we didn't give you any work to do to practice what you have learned. So now you are going to do this 2 exercises, exercise 1 and exercise 2, and you lately submit them to me. Please don't just write answers to me. Draw these diagrams, even if they are not nice, but let them show the information. Okay, so just go and draw these diagrams. Yeah, and then every answer should go with the diagram. Okay, guys, so please do me that favor. We are Abieta Tutoring. We are going to simplify the complex. Bye bye, guys. See you in our part 3 of the next video.